minutes and we'll start.
Okay.
Until sir, www. You can wait and you can talk.
No, actually, this is a Monday, no, sir. It's the first day of the working day. So,
Yeah. Okay, sir, correct.
So, just we'll give 5 minutes and
Yes,
we'll start.
yes, sir. Yes.
Okay, good, great. Thank you, sir. No, it's my pleasure. No, I will always available. I enjoy it. It is pleasure.
That is right. I will fine.
Ratnam garu speaker join ayyara. I mean, Amit garu.
Amit Gunnar, sir.
Yes,
Amit ji, namaste.
Yeah. Hi, good evening.
So, where are you, Amit ji, at present? Last time you were on the hills and some area where network was not there. So,
No. Today I just came back to office from a meeting.
Oh, very nice, very nice.
So, yeah.
Thank you.
Dr. MR, speaker.
Good evening, Amit.
Yeah, hello, good evening. How are you?
I'm good, thank you.
Good evening for all of you. Good evening, sir. Good evening for all of you.
Good evening.
I am Dr. Venkat Subaya, Chairman IA Telangana State Center.
Hello.
Ramreddy garu leru.
Join currently. Dr. RAMAKRISHNA. The one.
Thirty-five. 1 minute.
If you can start, sir, please.
Yes, sir. Sir, just 1 minute, sir. Chairman will be here, sir.
Okay. We'll wait.
Just 1 minute.
Yeah.
Just out.
సీతారాం బాబు గారు మీ వెనకాల ఉన్న ఫోటో కొంచెం కాస్త మీ వైపు అని కొంచెం జరపరా అది క్లియర్ కనబడుతుంది మీరు దట్స్ యా నౌ ఇట్స్
వచ్చేస్తున్నారు సార్ సెక్రటరీ ఒకసారి చైర్మన్ చూడ Right. Sir, I invite all the corporate members, live members, and all the participants to the Anmol Ramakrishna Endowment lecture. The title would be on precast concrete technology shaping the future of residential and commercial construction. It would be delivered by Amit Bade. He is basically Dr. Amit Bade, who head and precast initiative LNT India. I invite Venkata Garu, chairman of FIE, Telangana Exchange Center, and the convener for the event, Dr. S.P. Ansuri Garu, the past chairman and committee member, Professor Dr. Rannanai Garu, and past chairman and council member, A.S.N. Raju Garu, to this event. And before we get into the formalities of the event, sir, let's get into the paying homage and tribute to the to A. Ramakrishna Garu by garlanding and lighting of the lamp, the portrait of Anmol Ramakrishna Garu. Come.
If possible, can you switch on cameras so that we will take picture? Yeah.
Come to say.
Sir, thank you for patience, sir. Now we will get to the program. Sir, I request the chairman of Institute of Engineering, Dr. G. Venkata Garu, to take over. Thank you.
Brahma joining.
Good evening, sir.
Sir, meet you.
Respected chief guest, Dr. Manmohan Kalgal. 1 minute. Okay. Sir, respected chief guest, Dr. Manmohan Kalgal, technical advisor, and independent consultant. Keynote speaker of today's endowment lecture, Engineer Amit Berde, Head Precast Initiative, L&T India. Engineer B. Brahmareddy, FIE, Immediate Past Chairman, IA Telangana State Center. Dr. K. Siddhartha Babu, FIE, Honorary Secretary, IA Telangana State Center. Dr. S.P. Anjuri, MIE, Member IA Telangana State Center and Convener of Event. Dr. ISN Council Member of IEI. Professor Dr. Ramna Nayak, Committee Member and Past Chairman of IA Telangana State Center. Past presidents, past chairman, council members, committee members of IEA Telangana State Center, corporate members of IEI, galaxy of eminent engineers, family members of late Dr. A. Ramakrishna, ladies and gentlemen, good evening to all of you. It gives me immense pleasure to extend a hearty welcome to all of you to the Dr. A. Ramakrishna World Endowment Lecture, a very important, vital and interesting topic on precast concrete technology, shaping the future of residential and commercial construction. We are very fortunate to have stalwarts of eminent personality. Chief guest Dr. Manmohan or Igal, technical advisor and independent consultant. The keynote speaker of today's lecture, Engineer Amit Bade, Head Precast Initiative, L&T India, and we thank them for sparing their valuable time to be amidst this important event. I am glad to inform that the Telangana State Center of the Institution of Engineers, India, has been regularly organizing endowment lectures, which are totaling to 21 in 1 year. On the birthdays, in the honor of eminent engineers like Engineer V. Subbarao, Engineer M. Reddy, Professor K. Gopichand, Dr. J. Purushottam, Engineer J. Prabhakar, Engineer Koka Krishna Mohan Rao, Engineer S. Balakrishna Reddy.
Sir, getting continuous echo.
Sir, echo తగ్గించింది సార్ ఐడియా లేదా మీకు ఇక్కడ ఆఫ్ ఉంటుంది సార్ ఇంజనీర్ జీవి సుబ్బారావు, ఇంజనీర్ టి హనుమంతరావు, ఇంజనీర్ ఏపీ రంగనాథ స్వామి, ఇంజనీర్ రాఘవాచారి, డాక్టర్ నారాయణ తాతారావు, ఇంజనీర్ మాటూరు గోపాలరావు, ఇంజనీర్ గురం కోటిరెడ్డి, ఇంజనీర్ అట్టూరి వెంకటేశ్వరరావు, ఇంజనీర్ ఆర్ రాజు, జాన్ ఏ మురే, ఆర్ ఎల్ఎన్ రావు, వెంకటకృష్ణ అయ్యర్, Mel Swami, Ramakrishna, Engineer I. Lecture. The endowment lectures are being delivered by high eminence, professional experience to throw lights on emerging topics, space, relevance. I say a few words about Dr. A. Ramakrishna, the information of the elite audience. Dr. Anumolu Ramakrishna was born on December 20, 1939 at Unadipadu, Andhra Pradesh. He obtained his bachelor's degree in civil engineering in 1960 from Andhra University and MSc in structural engineering in 1961 from the College of Engineering, Indi, Chennai. He started his career in 1962 with Engineering Construction Corporation Limited, ECC, the then a wholly owned subsidiary of L&T Limited. The ECC was subsequently amalgamated the parent company and is widely known as ECC Construction Division of L&T. Dr. A. Ramakrishna, former Deputy Managing Director and President of ECE L&T. Ramakrishna is an acknowledged expert in the construction industry, known for introducing novel systems and processes, and played a central role evolving policies relating to construction sector. He has been the president of Indian National Academy of Engineers, INAR, Vice Chairman of Construction Industry Development Council, CIDC, and Vice Chairman of National Academy of Construction. He was an independent director in few companies. Dr. A. Ramakrishna got a 2007 Steve Sabag Award for Engineering Construction Excellence and an initiation of Engineer G.L. Rao, FIE. He donated the award amount of 4 lakhs to IEI AP State Center to institute Young Engineer of Excellence in Structural Engineering area under the style L&T Dr. A. Ramakrishna Young Engineer Award to be presented every year during the Engineers Day celebrations. Due to demise of Dr. A. Ramakrishna during the year 2013, it is proposed by the State Center Committee to organize an endowment lecture every year, that is 21st December. But this time it was delayed due to some reasons. Since you are anxiously awaiting to hear the talk from our eminent speaker, I am limiting myself and hope that you will really enjoy his talk. So lastly, on behalf of the Telangana State Center of the Institution of Engineers, India, and on my own behalf, I once again extend a hearty welcome to all of you to this important event. Thank you, one and all. Now I request Dr. S.P. Anchuri, convener of the event, to introduce keynote speaker.
Yeah. Namaste, everybody. And this is the 12th endowment lecture of Dr. A. Ramakrishna, and we know all him well. And then another person from L&T who is eminent in the field. It's very fortunate to have him here today. So I would like to introduce Amit Burde, who is a friend of all. He's the head of Precast Initiative L&T India. Mr. Burde is a seasoned engineering professional and the head of the Precast Initiative at L&T India, based in Mumbai, Maharashtra. And with extensive expertise in precast design and construction, Mr. Amit has led projects across the diverse sectors, including the residential buildings, data centers, warehouses, schools, office complexes, industrial plants, stadiums and parks, park decks, and the list goes on. Previously, before this, Mr. Amit served as precast design residential buildings head at L&T India and held significant positions at Metromont, where he honed his skills in structural design, performance analysis, and damage assessment of the precast concrete structures. Mr. Amit has extensive work, and he was involved in the designing innovative and sustainable precast solutions, ensuring structural integrity and conducting inspections to evaluate the performance, and he addressed many damages in the construction concrete structure especially. His leadership in the precast domain has contributed to the delivery of high quality, efficient, and durable structures across the India and beyond. So it's a big biodata, but this is told in a very brief. Mr. Amit, we have the cross section of the industry today with us, and people are viewing in the groups. There are some people are on YouTube, some people are from civil engineering, architectural background, electrical, because Institution of Engineering having about 15 streams. For the building industry, we require everybody, and it's a little challenging task for you to go through the entire process of precast, which is again another challenge in the country. So over to you. And people are from pan India. We can see from Bangalore, Kolkata, Delhi, Mumbai, Hyderabad. So the next 45 minutes are yours. Go ahead, please. Thank you.
Okay, wonderful. Thank you for the kind invitation, kind introduction. I'm sharing my screen now. I hope everybody can hear me well.
Yes, you can.
In the presentation full screen mode.
Yeah.
I am looking at about 30-35 minutes and about 5-10 minutes of Q&A.
Okay. Thank you.
First of all, I think, and I'm sure everybody here are aware, but Dr. A. Ramakrishna is revered as God in L&T. So I just wanted to put that on the record. In fact, one of the key reasons I'm here is my first interaction was with him when I started looking for some options to come back to India and in the precast industry. And I think L&T has started precast for residential and commercial about same time. So that's how I've known him. Unfortunately, he left us all very soon. So my interaction in person was very limited, maybe about 6 months or so. But till today, any discussion starts, may it be precast, may it be innovative construction, may it be fast construction, rapid construction, or in general, to be a good person or a kind human. I think Dr. AR's name comes up at the top of the list. So, with that note, we are going to primarily be focusing on how we have adopted precast construction in residential and commercial buildings now. Precast is not new, right? So, like I said, Dr. AR, he has been doing precast, pushing precast for last 25 years when he was here. We have been doing precast in many commercial large-scale structure. What you see on the screen is, of course, our Motera Stadium, or actually Narendra Modi Stadium now, one of the largest cricket stadiums in the world. And seating capacity, probably would have heard, is about 125,000 people. And the entire structure was constructed using precast elements, right? Right from the Y columns that you see in this picture to the stadium beams, raker beams, stairs, seating, everything. This is our high-speed railway construction. The girder that you see is about 40-meter long, 1,000-ton in weight, and fully precast. That whole construction of the entire elevated viaduct is being constructed in precast. If you talk to that team today, they are more proud about that straddle carrier that was built by L&T in India than the girder. The girder has been their mainstream day to day. They have been doing that for long. And that's where the state of precast is in infrastructure projects. If you come to Mumbai, this is our Trans Harbour Link, the Atal Setu, what we call it now, 21-kilometer long. And a significant portion of that has been done in precast. This one picture I wanted to put it, it's not precast girder, but it's a orthotropic steel desk, right? And why we are doing precast, the same vision is here, is you prefabricate everything off-site instead of doing construction on site, right? It doesn't matter. One of the new things why we say precast is because our industry is very familiar with concrete. So we are saying you precast the concrete somewhere off-site. But somewhere in the talk, you will see the focus is not on actually the technology. The focus is on how to improve the construction productivity, how to improve the quality, and you take it off-site. And what you see here is a 150-meter long section that is fully prefabricated on the coast and then brought on the barge. And if you don't get the scale of this picture here, which is very difficult, if you see, look at somewhere in the middle, this is where you see people, and that's how big that barge is. If you want to take a look at it again, right? It's almost a 3-football field wide, and all those efforts were done so that this one pre-assembled everything at the factory on the ground, assembled girder can be brought out to the site and installed. And when one of the last piece was installed, this is where I took that picture. This one girder, which is 150 by about 12-meter wide, was installed on the bridge in under 2.5 hours. Right? If you do conventional construction, even the rapid construction or assembled construction, it takes much longer than that. On the same side, we are building metro in Mumbai now, an entire underground metro sector that the precast comes. But again, that modularity, rapid construction, moving most of the activities to offsite. So with that introduction, I come to this one, where we are looking at why L&T is stressing on these technologies, why we are doing things, what we are doing, how we have changed the way we are looking at construction over the last 4 or 5 years. And in the entire presentation, I would have about 3 or 4 key slides, which I will let you know that these are the points that probably I would want everyone to take home. right? Everything else is project case studies and examples and pictures, but these 3-4 slides we feel is the crux of the technology, which entire engineering industry, entire the clients or the government agencies probably have to understand if we want to do business in this industry and continue to deliver. So if you look at that business excellence, what we call it, which is heart of this scenario, what we feel is that excellence going forward is going to come through two key things. One is mechanization, and this is where all these new technologies are coming in. And of course, today's focus is precast, but like I said, the crux or the heart or the core is the mechanization and digitalization. So these two things have been our new mantra since the last maybe 6 to 7 years. And for that business excellence, how we close that cycle is you use mechanization or various technologies and you monitor that efficiency. Like the entire focus is on productivity for various reasons. One, the project deliveries are shrinking. Whatever was a norm to construct a project in 42 months or 48 months has already become 24 months and 36 months. And when the tenders are coming at 36 months and 24 months, from inside, our management is asking, can you finish that in 18 months? Right? That's kind of volume and a massive amount of work is to be done. So that efficiency is being monitored through that digitalization, right? Digitalization is not being done just for the sake of it to do something fancy, is to monitor. And then when you get that data, we are trying to see, okay, based on that information, what we need to do next, what we need to innovate to further mechanization. And that's where that cycle is going on. And that cycle keeps going based on this continuous marginal improvement, right? We are in the industry which is fairly averse to drastic changes. If you see most of the last 40 years, we have been doing things kind of same things that we've been doing, but that marginal improvement, that's what we look at it. Precast we have done the last 10 years is keep changing, keep tweaking, never settle. Now, from that perspective, if we move to building construction, which is what the focus of today's is, we usually spread out those buildings in from low rise to high rise, right? So this curve, when we started discussing, okay, I want to deliver and I want to put a snapshot of the industry, we purposely drew it to an S-shaped curve, which is related to low rise. Low building is about ground plus 4 story. To mid-rise buildings is about 4 to 5 stories to about 30 stories. May it be residential, may it be commercial. And 30 stories above is something which is ultra tall, is the high rise. And now if you take that as a function and you take a derivative of that, the derivative is going to be this S-curve, where fairly flat is where I am very comfortable doing what I'm doing. I'm not really in search of something drastically different. Mid-rise sector is that 5 to 30 stories is where the rapid shift is going to come. We are getting a lot of volume. We want new technologies coming in drastically. We want the delivery timelines less. Client is asking again and again to reduce it and deliver faster. And then we go up again, super tall is where we are fairly comfortable because these are usually 1 or 2 buildings. Once you get out of the ground, you have climbing formworks and all, which we are comfortably building. There is no demand from the client side saying build faster. So we are so we don't see any drastic shift coming on. So most of the focus what we are looking at today, especially for precast, is that mid-rise sector where multiple buildings come in a project, very large volume projects. So I am looking right now where we have adopted precast. Last 2 projects is we had about 35 buildings. The one we are setting up factory now has about 11,000 houses. So the scale is that kind of project is where we are looking to deliver these technologies. And when I say that new technologies is the entire base is what we feel going forward is on your left-hand side is some kind of hybrid technology. Right? When you see in residential construction, for example, when aluminum formwork came in around 2000, it kind of swept everybody off their feet and everybody was looking at that. And even current today, aluminum formwork in residential is probably one of the most popular methods. Right? 95% of the work that we do in residential is using aluminum formwork. But going forward, we don't see that something like that will happen. It will be a combination of various technologies, so hybrid. But one thing is sure is where the industry is moving is it would be some sort of prefab off-site construction. And why we say that? Because working at site is becoming increasingly difficult. Inviting people, workforce, including the staff engineers, to the actual workforce or the gangs that operate, it's becoming extremely difficult. In fact, we have some internal guidelines where it's been discussed that assume that 5 years down the line, you are not going to have any people who will work on site. And that's where that mechanization drive is coming from. So with that background, if you see, generally building construction, these are the predominantly used technologies over the time. Of course, we had conventional formwork. In the 90s, we tried aluminum tunnel formwork. Then we shifted to aluminum formwork, like I said, from 2000 onwards. And then 2010, we thought that even the aluminum formwork speed is not going to be enough going forward, the kind of volumes we are doing. So precast came into picture, which is pretty much very similar in terms of the functionality, in terms of the user look, touch and feel to concrete buildings, just that the elements are done at factory level and then assembled at site. So these are some of the projects that right now I told you about PMAY housing. These are all total precast buildings. Whatever you see in the picture has been built in a time now of about 2 years, right? About 7,500 houses. And the buildings are there. What you see, except foundation, everything is being done in total precast. The finish and all, if you see on the right hand side, that there is no external plaster at all. The buildings get installed with factory made elements. They get treated and then they get painted. We don't do any internal plaster also. So maintenance wise, all those chips, spalls, cracks, water seepage, everything is very limited. All of this is M50 grade concrete. The buildings, when finished, look exactly same as what a normal building, RCC building will look like, right? The same balconies, chajjas, windows, whatever that is conceived. Of course, we have to treat the joints, maybe architecturally as well as functionally, but that technology, that dependency has been taken off. And something similar, we have been doing that, right? This is one of the first buildings that we did in Mumbai in 2014 time frame. So it's about 10 years these buildings are standing. In this picture, you see 3 buildings, but we finished total 6 buildings, about 2,000 flats. And the 10 years that building, we don't have any significant concerns. Then we delivered this one project in Bangalore, which is about 30 lakh square foot of built up area, about 3,000 houses. Again, these buildings have been standing for last 8-9 years. And this one picture I would want to probably spend a little more time is when you deliver or when you adopt a technology. I think a lot of focus goes on the engineering and detailing in L&T to make sure that the delivered product is very close to whatever the industry mainstream norm is, right? So if you go here, the detailing is done, a lot of engineering time is spent to make sure that the architectural elevations, the overall general look, touch, feel is same as the buildings that probably are built by the conventional norms. And not only from external, but even from within. We set up this mock-up flat using the same precast system. And this is one of the finished flats where you can't see it now, but even if you are standing close to this corner, there is a precast joint here. On the wall door, there is a precast joint. At the slab level, there is a precast joint. And once it's finished, even our own engineers cannot find where the joints are. Of course, those people who don't know where the joints are, but the time is spent to be or bring that finished product to that level. Not only residential, but even commercial we have done. Commercial is picking up now, but the system is same. Wherever you want the large spans, open spaces, the system changes from the classic load-bearing wall system for residential to a beam column frame system. And you will have a column element, you will have a beam element that will span about 8 to 10 meter. And then you have this either pre-stressed hollow core slabs. Outside world is using even the double T's and various elements. And that will probably come to India soon. But various systems are in place, accepted by the client. This building was done in 2015 time frame, which is if you ever come to Mumbai, if you go to the T1, which is a Santa Cruz Old Terminal, that's a parking structure that you will see on the left hand side. Again, building is operating for 10 years. Facade elements, we do a lot of work in that space. This again is a very unique project for IKEA. This is in IKEA in Navi Mumbai, where the steel structure and they wanted a floor slab in hollow core slabs. And of course, client came up with that. And we're glad they adopted it. But there, one of the main requirement was this is about a 16-meter long span, 750 kg per square meter full warehouse load. These are 400 deep slabs, but no shoring when the slabs were installed. Right? Because the floor to floor there at that level is about 8 meters. So we would have to do a lot of shoring. So what we proposed is one a single element in hollow core slab and about 50% less time compared to conventional slab construction that this was being completed. This is one of the substation buildings we handed over now in Vizag. 5-level substation building, one 4-level, one 5-level next to each other. Again, very heavy loads, all the openings, coordination for the routings, cable ducts, routing, all coordination done and total precast using beams, columns and slab elements and of course outside walls. So this one of the unique one again, where if you see the architectural vision or the perspective was that boxes and the vertical columns. And originally when the job came, this was planned in block work. So imagine this would have been a lot of block by block construction all the way around the building and then plaster it. So we said we will convert that the vertical ones. And since we were converting the verticals to match the finish, even we did the exterior cladding horizontal. So all that entire facade has been built in precast elements level by level and then directly painted. And that worked well in terms of productivity again. We took the next step, this project as a mock-up, because this next project is in Mumbai, right next to our office, where it's a steel building. So we said if a steel building and a blockwork facade, why not try precast with steel inserts or embeds that can be attached to the structure by welded connections. So we did this mock-up. This is attached to that steel structure. Later during the timelines and availability, finally we didn't do the project, but we are now proposing it at various projects because of that productivity improvement. So if I have to give that benchmark, this mock-up, each panel was attached to the structure in about 30-35 minutes with the connections done and crane doing the next panel. Equivalent block work will take at least 3.5 days with at least about 6 to 7 people gang. And this was installed by a 3 people gang in about 35 minutes. So that's the productivity what we are looking at. As far as you know what you're doing, as far as you know the engineering, design, detailing, joint connections are done, that productivity is enormous. Right? This is one of the project in Bangalore, if you would have heard some people. For DRDO building, it's a mission building for us, which we finished the building in just 45 days flat, a 7-story building. In that, surrounding structure was steel, floor were hollow core precast slabs, not hollow core, and the toilet unit. So we started doing that, saying to improve the time, the toilet units were actually produced offsite and then finished there. So whatever pictures that you see here, the fully finished unit was brought to the site and kept. Right. So again, the idea is not precast technology or steel construction. Idea is to work offsite and finish as much possible as work in that controlled environment on the ground and get it done. Now coming back to residential, if you see, we always keep saying, is this a rocket science? No, it's been used for a while. If you tour Singapore, all of these buildings have been done in total precast system. From outside, they don't even feel like that they are precast. So that jointing, detailing has evolved. Same we are adopting also. But entire Singapore mass housing, social housing has been lot of examples, lot of buildings standing for more than 30-35 years are there. Then that Vizag thing, I mean, not Vizag, the commercial building, we also use residential buildings in pre-finished toilets. So again, similar example, this is a toilet pod, what we call it in a residential building with all this finished inside that. So before even we construct, all this is offsite finished, including the accessories, everything are finished. And this exact pod is left at site, installed, and then the surrounding structure is being constructed. So we set up a factory right next to it, and this is all where it gets finished, right? So You produce the elements here, if you see my pointer, and then you keep it here, finish everything, and then directly lift it off and put it in the structure. So this is not a child workforce. This is my son. I took him. It's an old photo. We did this project about 7 years ago. He's much bigger now, but he still talks about it 6 years down the line. That why don't you finish the entire building itself? Then why just the rooms? And we'll probably come to that stage also. But if these people are talking about it, I'm sure the engineering community has to pick it up. Now, I told you about those 3-4 slides. So 2 are already done. This is one of the third slide. Why we are driving again and again and where we are coming from is this is our own internal data, our own sites where we are having one aluminum formwork site at the same location, maybe about 3-4 kilometers away. So same team, same project director. And we started looking at the data, actually, what is the productivity that I'm getting? And if I look at aluminum formwork, if I track that 1 cubic meter of concrete, I'm looking at about 5.5 people required to finish that 1 cubic meter of concrete at site. If you look at that further split, that 5.5 goes, that actual concreting activity is about 1. The shuttering, tying the formwork and everything is about 3. And then rebar work is about 1.5. Those are the key CSR activities, what we call it. If I switch to a basic precast conventional factory, not a very state of the art, nothing circulator and all, that 5.5 quickly becomes 3.5, right? About 30% productivity. And that's what the benchmark is. If I start looking at something little more fancier, circulation, semi-circulation, some automation, that 3.5 becomes further 2.5. So overall, almost 50% of the productivity if I put that money in. But what we are looking at, and this is all at large volume, this is all at the construction is being at the same cost. It's not like we are pumping in money, right? The projects we are doing, finally, we are there to make money, and that cost is always important. So you at that volume, you get that money back. But the key item to look at it is all this 5.5 man power or the workforce is at site work, entire work. But here, if you see, at site is only happening 1.5. So the one of the biggest thing what is driving us is that reduction on the site activities, which is almost 70%. And today, any project manager, any project director, if you ask what is one of the largest risks that in their mind is, I have that plan. I know I can do this work in 8 hours. Whether those 10 people required will be there or not. And if they are today, whether they will come tomorrow. If they come tomorrow, whether they are coming in next week, or I have to hunt people and get them out. And this is where we are looking at this factory or the controlled environment is people like to work on ground. People like to work in the factories. We don't have that workforce anymore who is genuinely interested to work at site and climb 20 floors every day, even with the elevators and work on that level, right? We have much better jobs available than working on the sites. And day by day, that whole thing, what we are looking at, workforce reduction, whether skilled, unskilled is a separate sector. We just don't have people who will want to work at the site. And that's one of the biggest reasons why we are looking at these technologies. Now, when it comes to now system, okay, we have seen various projects. We have been using this technology, precast technology for, I think, last decade or so. We get various questions. We have a lot of questions. And if I have to summarize all those questions and concerns and with the weightage, right now, we have these 2 things that come to my mind that are of key interest that anybody wants to adopt. What are those 2 things is one, whether the joint by joint construction, element by element construction, whether for the seismic design, it will be performing adequately or not. And second, again, is if you do these joints and all, how do the structures behave or respond to leakages, seekages, or water? So I'll just quickly go over those 2, and then we'll more or less conclude. So first question is structural integrity, structural performance. And when it comes to that, we are 110% confident with the design detailing approach, what we have done, what we have adopted over the last 10 years. Will work in all those kinds of requirements when it comes to seismic or any lateral loads for that matter. We have done our own set of full-scale tests. So one of this is in front of you where we built a full-scale specimen, 3 meter tall twin shear walls. So imagine 2 shear walls like it's shown here. next to each other with a slab, and the slab carrying about 10-story dead weight to simulate that. And then we shook that element in a reverse cyclic control mode back and forth to gauge the response. Now, the idea here was not to see how the specimen works. The idea was in comparison with cast in place, how does it work? So one specimen was tested in the exact same setup, which was cast in place setup. And then 3 more specimen we tested with various types of joints and the approaches that we do. And the again idea, like I said, we are using this emulative detailing, which is wet construction. You stitch the elements together. We are not using welded or bolted connections. And that emulative, we wanted to see whether it will perform same as your cast in place or not. And this is a classic, that force versus displacement curve that was evaluated in an engineering terms. Generally, the area under that curve is going to be your ductility indicator or the R value. And that experiment worked flawlessly. Most people are quick to respond saying cast in place and precast. But this red dotted line, SW1, is my cast in place benchmark. And then those 2 precast specimen, which we used to use older connection, they kind of gave that exact same performance, right? So that R value and ductility were same. The last one, SW4, was with this grouted coupler connections, which work slightly differently, specifically for precast industry. And that gave me a higher ductility or higher R value. And why is that? Is because of usually the confinement, the metal tube confinement that you will get. And we tested these elements also separately. If you see, this was done at that time. This is 2016. We did not have any setup here, which will do the reverse cyclic test. So we took the specimen to a lab in Hong Kong, Castco. And the way these are tested is, if you see this graph, these are tested reverse cyclic, like same way we did the lab experiment. The coupler is grouted, cured to the strength, put it in the tensile setup, and then it's pulled to 95% tension and pushed to 50% compression. And we do 20 cycles like that. After that, it is pulled to twice the yield, 4 cycles after that, and then it's pulled 5 times the yield and 4 more cycles, and then it's pulled to failure. And the requirement is the bar has to fail, not the grouted tube. Right? And that gives you that classic ductility of that connection system. And you'll see that in every setup, these bars, the classic, the ductility hinge form, neck form, and then it that tells me that these grouted connections work in terms of the seismic and then the full scale specimen itself. So then we did the full program of other joints, vertical joint, the diaphragm joints, and in all aspects. Again, I would like to reiterate, the connections we are using is been used for more than 50, 60 years outside. So it's the same thing we're repeating, but for our own due diligence, for our own detailing, we verified that. And this is where that confidence is coming of 110%, or this is where we have these several rounds of approvals for this technology because of that emulative detailing. Right? Down the line, maybe we'll evaluate welded, bolted connections for commercial and all, but that's a very separate story. But right now, what we are doing is exactly this, which is where that structural performance will be ample. Now, the second thing, right? What is your performance against water? Now, here I am not as confident, right? Here I would probably say that, okay, 98, 99% the structures behave, because concrete itself is a permeable element. No matter how much you do, how much you waterproof, water is going to find its way. But I would confidently say that it is performing better than your conventional systems, right? So to give that example, this is a classic SOP that we follow when we treat our joints and all. There are 4 or 5 different level of defenses built in. But to verify that, each flat that we are building and delivering now gets fully flooded by 1 inch water, and that the water stays there for 4 hours. And after that, we look at all the joints, we look at the flats below and see if there is any leakage, seepage is there. That 98, 99 is where 2-3% we find that leakages, then we repair, and then we test it again to make sure that it has been controlled. So confidence level, yes, I wouldn't have 100% confidence, but we are doing 100% efforts to make sure that all these flaws are detected. Same way for external We do external testing. There are codes available now. There is IS 15916, which specifies these requirements. Of course, internal we are doing on our own, but 15916 will specify for external. But all these joints are getting tested. And where we stand today is we don't have any leakage issues in precast or joints. We do see some seepage, which is a very different structure, very different phenomenon that you see the moisture and then it disappears, but we don't have dropping or dripping water challenges, right? Based on whatever engineering we do, detailing we do, we score our buildings, we track that everything, and that is being recorded and given, right? So those two concerns, I think, of course, we'll have a Q&A also if you want to go in more detail. With that, I think I'm about maybe 5 minutes extra I'll take, but we are at the end of it. Just going through the current project, just so that you get the flavor of it, what we are doing, to what scale it is suitable, right? So I mentioned earlier, we are doing right now 2 projects. One is with it's about 7,500 houses. And then we got a repeat order for about 11,000 houses where we are setting up a new factory, which will go in operation from March this year. But this is that project, right? So elements like this is where this technology comes in, fits in beautifully, right? If you look at this scale now, about 8 flats per day, right? If conventional construction, if they say that I don't want really 8 flats, the 2 flats a day is enough, then this technology is not for you. It would not make sense also. It would not be economical also. But the current project we got is 11,000 houses, and the client said that it has to be finished in 36 months. And in that time constraint, precast construction is actually slightly cheaper than doing aluminum formwork construction, because at that 36 duration or structure completion of 24 months, the number of formwork sets that I would have to mobilize to guarantee that timeline would cost more than setting up the precast factory. And that's on paper, right? Where we say that every 15 days aluminum formwork will give me one slab, which actually with the challenges and everything goes to about 17 to 20 days. Whereas precast in that same cost, what we are operating is about 8 to 9 days per floor cycle. So, and that's where it makes sense. Large projects, this is the project in view. This is, of course, PMAY mass housing, but Hafiz is the contractor. So no way it is a typical traditional PMAY building. They wanted the buildings to look and feel, or in fact, to have their signature. So if you see the elevations and the bands and grooves at the bottom and top were very carefully done. This is just a typical floor, how we are sizing up the elements and building that floor up so that it can be built faster. We set up these, what we call is temporary factories, but by no means these are temporary. They come with a full shade, the whole 9 yards, the same quality lab, same concrete batching plant, which will pour concrete at that same level. Just that in 3 to 4 years, we will scrap this off, because we set up the factory at that project site itself, so that we don't have to have the challenges of the infrastructure, transportation. We don't have that road network where we can efficiently transport big. Hopefully it will come. So that's why we call this temporary factory, nothing else, but it's a full-blown setup, various molds, some imported, some doing in-house, and these buildings are there in front of you. Right? We use various digital tools also to track these buildings so that we can use that. So that's that circle I was mentioning, the mechanization versus digitalization. So we have now BIM adopted what you see, including each single, even a number 6 bar gets modeled. And at the click of the button, I get the 2D drawings. Even the mold drawings are being generated using that same model. And once we have that, each element gets tracked. So that level of quality, what I was mentioning, each precast element, what we are now issuing, I have the record where when it was cast, using what kind of concrete, what strength it was demolded, who signed the checklist, where it's been stored, when it will be picked up and shipped on the track. At any given time, how many panels are sitting there in the factory, how many are on the truck, to how many are actually being installed at the tower. And everything is being tracked now real time so that we can know what the real productivities are and what the workforce and amount is. So with that, we are at this last concluding session, maybe section is, I mentioned, I think we are building about 6 to 8 days cycle for per floor of about 450 square meter. It changes per the floor size. But last 2 years we have been doing that, and one of these days, I think when our one of the top bosses came, he said, "Okay, this 8 to 9 is fine. 30% you have shown, but what best you can do?" And in those discussion, the challenge came up saying, instead of these 8 days, can you do this in the 3 days per floor? And we said, yes, we can probably do that if you give us a lot of resources. So then discussion was, okay, don't worry about the resources. You ask me whatever you want, I will give you, but show me what best you can do. So what we did is, if you see this picture building, these are usually the way we operate is 2 buildings, and these are the same buildings what I showed in the picture. So 2 side-by-side building, there is 1 crane, and that caters to 2 towers. Now we said that for this 1 tower, if you want to build fast, give me 2 cranes that will cater to 1 tower. So it's as good as having 4 multi into 4 factor, right? So he said, okay, you do that. And I will come back to the number of crane, because most times people start thinking, saying, oh, that's a lot of extra money. Then we said, okay, crane is there. Usually the way we operate is the truck comes from the factory with the element, and then it gets lifted off from the crane. It's the just-in-time approach. But that usually doesn't work well. Sometimes the crane is doing something else, so the truck waits. Sometimes the crane is ready, but the truck is not there. So we said we'll store all these elements, whatever that is needed for the crane, on the ground itself. So whenever crane is there, crane should always be installing elements and never sit idle. So that was the storage that we, with these 2 minor changes, 8 days per floor was changed to 3 days per floor, right? And that's how we have built this building. Right from ground floor, first floor itself was built in 3 days, and then each floor we tracked it. I'll show a quick movie also later. But in 36 days flat, that structure was built, right? We did even the precast water tank for that challenge, because we wanted to finish that building in 96 days, because the building has 96 flats, a 12-story building with 8 flats per floor. So we said mission 96 is to finish. So 36 days to build the structure, and then another couple of days, I think about 60. The finishing started in the 10th day, because it was precast after the first 3 floors were done. But in about 76 days finishing, this building was handed over in 96 days exactly. Now coming quickly back to the crane. The total man hours or the crane months that we tracked later were actually less than what was planned if it were done by one crane itself. So resources, even if they appear more, because of that productivity, the net was in fact less. Productivity was how much more is on an average. Usually these cranes will install about 20 to 25 elements a day. With all those challenges that crane element is not there, crane is tied up, factory element is not there, and all that. Here at peak, that same crane has installed about 40-45 elements per day. So at peak, we install almost 92 elements per day. And that's where that cycle time reduction actually pays off automatically on its own. So it feels like the resources are more, but at net, maybe some marginally about 5 to 6% more was spent for this productivity improvement, which is drastic. Right? Of course, various digital tools, we will explain that. I don't have time to go over. One of these things is all that 36 days is absolutely without any safety or quality incident. And why 36 all the way to 96 days? So we had that tagline when you open this is without that safety and quality, your speed has no meaning. And with that, this mission was completed. I have about a 3-minute video on the same, just so that you can look at it real time and get a feel of that. I hope that is okay. I think timeline wise, I know I've already probably just about 30 minutes. So if that's okay, I will run that video. And then
you can.
I shared with audio, so you should hear the audio itself. But All right. So with that, again, thank you very much for your patient hearing, and thank you very much for the opportunity to present.
Yeah, thank you.
Thank you very much, sir. Dr. Ramit Bade garu. So your lecture is interesting and more informative, and particularly the latest technology you have shown for all of us, sir. And that is the day of need for our Indians, because the infrastructure in India is going at a faster rate.
Yeah.
And for that, I think your technology is helping more. So it is an excellent lecture, sir. And we are very fortunate to have a lecture like this. And I am also thankful for our convener, SP Anchuri garu, for arranging excellent speakers for this important endowment lecture, sir. So once again, I extend my sincere thanks for you, sir.
Thank you.
So now I request SP Anchuri garu to introduce our chief guest, Dr. Manmohan R. Kalgal.
Yeah. First of all, thank you, Mr. Amit. And now, after Dr. AR, we have another name in our Indian industry, that is Dr. MR, that is Manmohan R. Kalgal, because they both were very, very closely associated. And in fact, when he was the president of, Mr. MR Kalgal, when he was the president of ICI, they were instrumental in bringing in the handbook and all. So it's my pleasure to introduce him to all of you. Dr. M.R. Kalgal, he's BE Civil from BMSCE, Master's degree in Pre-Stressed Concrete Structures from UVCE, and PhD in Concrete Structures from Indian Institute of Science. Dr. Kalgal spent about initial 22 years in the teaching, research and consultancy in MS Ramaiah Institute of Technology, which is in Bangalore, and worked next 20 years in the industry in the field of pre-stressed concrete structures at BBR India, and new product development and technical services at Ultratech Cements Limited. After superannuation as Joint President Technical Services at Ultratech, he is presently serving as technical advisor and independent consultant. Dr. M.R. Kalgal is very active in several professional bodies and was Secretary General of Association of Consulting Civil Engineers, past President of Indian Concrete Institute, past Vice President of Indian Association of Structural Engineers, Asian Concrete Federation, and he has received several accolades, including Eminent Engineer by Institution of Engineers and Lifetime Achievement Award by ICI. In fact, sir, if you remember, Dr. AR, when you were president of Indian Concrete Institute, and we had this Concrete Day celebrations in 2013, and he was flying from Delhi to our program, and unfortunately we couldn't have him on the next day, and it's an unfortunate thing, but he is in our hearts and he is close to all of us. And we have, sir, Dr. RAMAKRISHNA, many like Ram Prakash sir and Srikant Chanal, who is in this particular webinar. I would like to have some comments or views after your address, and which can be interactive, because there are no questions to Mr. Speaker. So I think we can end with the interaction. But over to you, Dr. Kalgal.
Yeah, thank you, Srinivas, and good evening, everybody. I have been observing Anchuri in this field of architecture and engineering, where he has excelled in both the fields, and he has made a real mark. Of course, thank you, Srinivas, for reminding us about AR and his interaction we had during the precast handbook. And he was a wonderful leader and a very, very amiable person. So it's very apt that a person from L&T, Amit Bade, has been requested to speak on the topic of precast, which was a pet subject for AR. And in fact, he is the father of precast and pre-stressed in building sector especially, and the infrastructure sector as well. I've been observing Amit for quite many years now, and he has now mastered the subject of precast amongst all other things he is an expert in. and he's also a very good presenter. So I'm happy that, as usual, the talk was excellent, and he really covered a lot of things that needed to be covered. So I just thought, of course, I don't have any presentation to make, but I just thought one or two things which can also be now included is about sustainability in construction. Everybody talks about, sustainability, whether your construction industry is damaging environment and so on and so forth. In fact, most of the consumers are concerned with the present and future health of the natural environment. But unfortunately, very few are willing to pay more for the building product or process or even innovation that minimizes the environmental burden. Fortunately, the concept of sustainability balances sustainable design with cost effectiveness as well. So, coming to precast and sustainable construction, we can say that they follow what is called as the integrated design, which Amit did mention, which is also called the holistic or whole building approach. Anjuri is also an expert in this. So the building materials, systems, design, all of them are kind of woven together from the perspective of all the project team members and the consumers or tenants. In fact, energy efficiency, durability. Durability is again another tenet for sustainability, space flexibility. All these things are considered when decisions are made regarding the selection of building design. Precast concrete very largely contributes to sustainability by incorporating this whole building or holistic design approach, or what we call as integrated design, and also using the materials very efficiently, cost effectively, virtually no wastages and so on. So there is a great reduction in construction waste, site disturbance and noise. All of these are reduced. Even the production of precast under controlled condition itself will ensure a lot of things that are required from sustainability point of view, especially handling the wastages and noise and pollution and so on and so forth. Now, what more is required? Why did, in spite of, and precast is not new actually, it's been there for quite many decades now. But why is it that in India it was not popular, or it is still not yet popular? Is because of several things. One is probably we were not having any issues of constructing at speed, and we didn't have the volumes that are now in demand. Now both speed and volume are top priorities, which is possible only with precast. Similarly, the people who do the construction, they are becoming lesser and lesser, and we have very great scarcity of available workforce. This again is leading people to go towards precast. And of course, we have mechanization, which was not there. Mechanization in manufacture and assembly, both were lacking. So precast industry took a little backseat. And one major thing is to note that the constructions that Amit is talking about, they are all tall structures, super tall structures, and large structures, large span structures, etc. If you look at the total volume of concrete that is consumed or construction that is there, they are only about 3 to 4%. The 94% or 96% of the construction happens in individual houses, and these individual houses, precast has not made any leeway yet. So what we need is basically modularity, which is not there. Only if there is modularity, there is repeatability. Only if there is repeatability, there is economy of the whole thing, and sustainability maybe. So people, architects especially, have to look at modularity and some kind of standardization, which will enable precast to move into a huge area. If that happens, And if, like what he mentioned, Amit mentioned about 3D modular precast or prefabricated, pre-finished volumetric construction, we call as PPVC. These can really bring in, revolution in the construction industry in terms of volumes. Of course, mass housing is not the only answer for this huge country. We need tier 2, tier 3 cities to have probably a kind of hub and spoke model where the precast elements are available. They are small enough to be traversing the distances. One another issue is, of course, the roads. The road network may not enable this hub and spoke at all places, but then that's the way to go. And lastly, the clear understanding of the jointing mechanism. Of course, L&T more or less follows monolithic kind of joints and not the weldable or boltable joints. But then clear understanding of this by the designers and the acceptability by the common man, because they feel that this will collapse like a pack of cards. Of course, if it is not done, it will. But then now there are hundreds of examples from California to New Zealand showing that even under severe earthquakes, precast can withstand as good as any, this aluminum formwork method or whatever. So all in all, we definitely need to look at making precast available and making it available at far flung areas in the country. And from the sustainability point of view also, this is the way to go. So I'm very happy that the IEI Telangana Center has organized this talk on this very important topic. And I hope it will pave way for more and more people to take up precast as the route. Thank you very much.
Thank you, Dr. Kalgal, for your address. In fact, sir, in amongst the audience, there are steel giants. Dr. RAMAKRISHNA, who, as per me, he's a steel giant and he's listening to precast. I would like to have his views. And we have another person who is a instrumental and backbone for the civil engineers bill in the Karnataka, including you all. But Srikanth is there. Mr. Srikanth, we have Mr. ISN Raju and others, those who are the council members from Hyderabad for IEI. And other day, our president, new president, Mr. Singh, he was talking about the engineers bills in general, but you could bring the civil engineers bill. So in very brief, can you just give us idea how to go about it so that IEI Telangana Center can also work on that line to get the Telangana Civil Engineers Bill or as an engineers bill? Even Dr. Kalgal and all others were instrumental and to bring it, and the congratulations for that. And we have Mr. Brahma Reddy was instrumental again to make this particular, because why I'm saying is Telangana IEI is the center which is record-breaking center. Since 13 years, we are getting the best center award, and all the chairmen, they are here, and I am just one of the soldier, but captains are here. So over to you for a few seconds, please.
Oh, thank you, sir. Thank you, Anshul sir. I enjoyed today's lecture, and in fact, I was into this pre-construction for quite some time at Saravati Railway Bridge. We had 33-meter box girder, pre-tensioning, girder launching, and things like that, a part of it, maybe. But altogether, the total precast, the things that are turning today is altogether a different arena. Okay, having said that, now you requested me about the Civil Engineers Act that was necessary, and which I think somehow our team has achieved it. I cannot say that particularly this thing. We have some core team, and the core team has managed to travel around all over Karnataka and this thing. The basic thing that we made this thing is our homework, that how to convince the people, because our own engineers were not aware of what we need to have and why our profession is going into such a bad situation in the society. We don't have recognition, and we don't have that particular respect that one profession need to have. And we collected lot of data from across the globe, which are the countries that have already the regulation, like small countries like Pakistan, Sri Lanka, Indonesia, and many other countries. About 90% of the countries have already regulated, whereas very few countries like India doesn't have. Whereas if you consider the economy of the country, we are the fifth biggest economy, and we are the third largest construction in the world. In spite of all this, we are not giving importance to the civil engineers, who are the backbone of the construction industry. And if you take the economy of the this financial budget and other allocations, last year, if you see, 10 lakh crores has been allocated for the construction of the government sector. And if you take the private sector and other financial contribution into that, it comes around 38 lakh crores, which all put together is 75% of the whole Indian budget itself. So what I mean to say here is, so much of important is the construction sector, and it is the second largest employment generating sector. Everybody knows about it only after the agriculture, and it is one of the highest return for any investment, 80%. And things like that. There are many this thing that I can give you. These are the economic part of it. And if you look at the other professions within India, there are, for example, you are the architect, your profession is regulated. Of course, you are engineer also. And there are doctors. In the doctors, dentist profession is regulated. This allopathic doctor's profession is regulated. Unani medicine is regulated. The lawyer's profession is regulated. This company secretary's regulation, chartered accountants, things like that. Almost all the professions have regulated except the civil engineers. And civil engineers are the largest and the oldest profession in India. And if you consider roughly, we are about 1.25 crores civil engineers in India, all put together. And this doesn't have the recognition. There are many incidents that lead to catastrophic failures or catastrophe to the economy, and very bad situation we have faced during Bhuj earthquake, wherein 85%, as per the report from the expert committee, 85% of the buildings that were devastated were low-rise buildings, and those low-rise buildings were constructed without the involvement of technical people. And these are the things we experienced in Bangalore also in 2021. In a span of 45 days, 9 buildings collapsed like pack of cards. And when we investigated, we also got the same result. And that was the ignition. And we studied there also in detail. We made several committees, and we conducted a national level professionalism and civil engineering seminar. Probably you are aware of it.
Yeah,
it was a 10,
sir, it's a really great thing. So what we can do is we will, arrange one half day or 2 hour session, especially for you and other experts, so that it can be taken further, because it's now ending the session. So, but thank you very much for your insight. And you ignited it. Now we will take it to further. So, I request our chairman to arrange special a session under the civil engineering domain, so that we will initiate in our Telangana to go for it. And before we hand over to you, I would like to listen just one line from Dr. I.S.N. Raju, because he is from infrastructure. Because infrastructure is different. Buildings are part of infrastructure, but he is from the irrigation and other sector where this precasting, and just one line, sir, if you are there. Dr. I.S.N. Raju. Or in the meantime, one line from Dr. Ram Prakash. And then over to Chairman.
Mr. Anchuri?
Yeah, please, sir.
Am I audible?
Yeah, you are audible, sir.
Okay. I wish to pay my respects to A. Ramakrishna, who was a great friend of mine. And We bumped into each other in the 80s when a multi-story building was built in here, the back building of 16 floors. And I found him to be one of the most patient person in hearing you, and then appropriate technologies, and also with project management. And then after that, we started AC in Francisco, where very simple, both of us are sitting next to each other, India session, making a presentation. And then we found that the slides had to be operated yourself, the speaker. So RAMAKRISHNA at each other, and I said, we got ourselves, not like in India. If you want, I'll operate my slides, So that is RAMAKRISHNA for you. Great man, we have lost, and I feel that this memorial is an apt, shall we say, subject to youngsters to think and work like him. The thing about precast, very well put by Mr. Amit Barde in such a short time. The thing was that I have done some precast construction. Right from beginning, I wanted to do a lot of precast construction. What I found was the apprehension of the person on the other side of the table. The person at the other side of the table always having apprehension about precast. And the second thing was the government was saying sales tax was imposed on precast. So it became, but technologists of civil engineers and project consultants, the innovation was the key. Through innovation, these were taken care of, and through testing, much of the apprehensions were removed. You were right. When I went in the 80s to Europe and the US, I found most of them doing steel. And I was wondering why we don't do steel here. And that's also because people are not, they are very apprehensive about the weld, about the actions, So that was one of the things why steel was not taken off here, although I did structure of meter diameter there and all that. Now, with steel combined with concrete is going to be one of the major things that I think we should foray into. And as rightly put by Dr. Kalgal, modular construction is the back of this. And finally, as told by Mr. Amit Barde, I had seen in 80s itself the 2 tower cranes in the West, where we used to struggle to tower for multi-story. But as Mr. Badre has told correctly, all these things have worked out without it. Then only success will be assured. And I also wish to compliment Mr. Badre for a fantastic presentation in such a short time. Thank you.
Oh, thank you. That was Dr. Ram Prakash from Bangalore. We have Dr. ISN Raju Garu, who is again council member and very active and very eminent personality from Hyderabad. Sir, over to you before we hand over to Chairman, sir, please.
Good evening to everybody, sir. I am damn happy. Actually, when I was the chairman of the then AP State Center, Dr. Ramakrishna Endowment Lecture was installed.
Exactly.
The institute stated, and the Anchuri has taken a lot of efforts for that one. And one unique thing is, right from the first endowment lecture till today, only Anchuri is the convener of this Ramakrishna Memorial Lecture. And we are very happy. And our Institute of Engineers is very grateful to Ramakrishna Garu. One incident I would like to tell. He got an international cash award from IEI platform. So the entire amount was donated back to our IEI. So that is one of the magnanimity of Ramakrishna Garu. And one more thing is, Hyderabad never forget Ramakrishna Garu. So Ramakrishna Garu, actually he introduced a lot of innovations in Hyderabad. High-tech city of its first of its structure came into Hyderabad. And we are very thankful and grateful to the actual today's chief guest and guest of honor. They have given a wonderful talk on precast concrete technology. Sir, it has proven and everybody is accepting that the best quality can be achieved by this precast technology, because otherwise in situ construction, So we are not sure that we cannot present ourselves 24/7. So we have to rely on some of the subordinates. So now precast is the only way where faster construction can be done and quality can be assured. Thank you very much, sir. Thank you, one and all.
Yeah, thank you. Mr. Birthday, we have one question about Mr. Pratap Babu is asking any cost comparison chart between the conventional and precast structures for different floors and systems are available, or can you have some word on that?
Yeah. So I wouldn't say per floor or anything that we have, but it depends, like I had mentioned, on the volume and the time that you look at it. So it has to be a case by case study. Where I can give guidelines now is in terms of quantity. This we are almost as good as the way we have done now engineering and all, almost as good as your conventional cast in place systems. Maybe for some connections and all, about 0.5% more in terms of your steel consumption. Concrete is as good as same. And overall technology cost, if you see at our large scale projects, about 5 years ago, it used to be about 3 to 4%. Today's with the schedule crunch and all, like I mentioned, it is almost same. And in fact, at that large scale project, what we have taken up now about 6 months ago, it came slightly cheaper than conventional construction itself, if you have that volume and scale. So I wouldn't want to put a blanket because a lot of things vary. It's as good as your shuttering cost. If that shuttering at a scale where your shuttering cost and a precast factory cost starts matching, you are a break even. So
Thank
you
you,
have to
sir.
look at
Thank you.
individual premium, whether what premium or how much you have to do per the schedule, or do that math individually. To the best of my knowledge, there is, because once the material quantities match, it is just a game of math based on the volume and what number you'll put it on.
Thank you, sir. Thank you very much. Today we have very lecture on very important topic, that is the precast and how it is useful for the faster infrastructure growth in India, and also how it leads to the sustainability. That is a very important aspect which is added by Dr. Manmohan K. Kalgal Garu, and valuable address was given on this occasion. So once again, I extend my sincere and profound thanks for all of you, sir. So now I request Dr. K. Sitaram Babu Garu, Honorary Secretary, to propose vote of thanks.
Sir, some people they are asking about the recording, so it's on the YouTube, so they can, that is available.
It's already in the YouTube, sir.
Yeah. So then you can opt it. Okay. Thank you.
Sir. Yeah, sir. Thank you very much, sir. I should really thank the excellent topic that we had today, sir. On Dr. A. Ramakrishna Gari 12th endowment lecture, sir. Precast concrete technology shaping the future of residential and commercial construction. I thank the chairman, Dr. G. Venkat Subbai Garu, and the convener of the event, SP Anchuri Garu, for having made such a wonderful lecture, sir. I think it's one of the best that after I became secretary to hear, because one of the important topics are more relative to the future infrastructure development. And I also thank Dr. Manmohan Kalgal Garu. He is basically a technical advisor and independent consultant, for having been the chairman, and he has opened his experience and his expertise also, sir. I thank Dr. Amit Bade, the head Precast Institute of L&T India. Thank you very much, sir. Such a wonderful lecture. I was also part of L&T Infotech, sir. I just worked for 1 year at Powai, sir. Later I moved to Chennai, and then I was in SAP practice, sir. And I also thank our senior people who are part of it, sir. Dr. A.S.N. Rajagaru is the past chairman and also the council member. B. Brahmareddy Garu, immediate past chairman. And Professor Dr. Ramana Naik Garu and Rama Garu, the committee members of the Telangana State Center, and Narmada, and many more life members, corporate members, and research scholars are also in part of this, sir. I thank one and all for having been part of this, sir. I also thank Dr. Srikanth, Dr. Ram Prakash, and Dr. A.S.N. Rajgaru for having added some flavor by giving their expertise and their knowledge to the entire theme of precast concrete technology. I thank one and all. Before we end up, sir, we all stand for the national anthem. Thank you.
जनगण मन अधिनायक भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, sir. Thank you. See you all. Thank you.
Okay, thank you all.